The following is from Summer 2009 Math 263 Test 3 number 9C. The question is to find the volume of the solid. Let's see again the question. The solid is bounded above by paraboloid c equals to 8 minus x squared minus y squared, and bounded below by another paraboloid z equals to x squared plus 3y squared. Now in part A we already see the intersection of the surfaces, and this will tell us the domain of integration. Now we will continue from that part A. Okay, if we take a look on that one, then the volume of this solid equals to the integral from -2 to 2, integral from the upper bound there. Let's see, what would that be? That would be from negative square root of 4 minus x squared over 2 up to square root of 4 minus x squared over 2, and then the upper bound is the 8 minus x squared minus y squared, minus the lower bound is x squared plus 3y squared dy dx. Okay, I get the domain of integration from that ellipse there. Now we do expect that this solid is symmetric with respect to xz plane and the yz plane. Therefore, I will use the symmetry and make it into 4 parts, and the integral now will be from 0 to 2 here, and the one here will be from 0 to square root of 4 minus x squared over 2. Okay, now let me simplify the one inside. This will be 8 minus 2x squared minus 4y squared dy dx. Okay, notice that I can factorize another 2 out. Let me do it now. 8 integral from 0 to 2, integral from 0 to square root of 4 minus x squared over 2, and then here I have 4 minus x squared minus 2y squared dy dx. Now let's see. What I will do next, I will do the following. I will integrate with respect to y, integral from 0 to 2, and then this will be 4 minus x squared y, because you can consider this as constant, right? This is as a constant, and then minus 2 over 3 y cubed from 0 to square root of 4 minus x squared over 2 dx. Okay, and then from there I will plug it in. For y equals to 0, we can omit that, right? So this will then be 4 minus x squared, and then the square root of 4 minus x squared over square root of 2. That's for the first term. In the second term, there it will be 4 minus x squared over 2. That's for the y squared, and square root of 4 minus x squared over square root of 2 dx. Is it okay? Now then, I will do this little game here. Notice that this is a common factor, right? Okay, and I can cancel this. Okay, so I will rewrite that common factor now as 4 minus x squared to the power of 3/2. That's the common factor. And then inside, if I factorize, I will get 1 over square root of 2 minus 1 over 3 square root of 2 dx. Now we know this is kind of painful. Now if we compute this later on, you will see that's actually, I think that will be, let me do it. 0 to 2, 4 minus x squared 3 half, and this is 3 minus 1 over 3 radical 2, right? And therefore you will see that's actually 8 radical 2 over 3, right? Because this 2 here cancel with radical 2 on the denominator, you have radical 2 left, and then the 3 goes down there. Well, anyway, that's the little algebra. Now then, if we continue, the guys inside, I will do substitution. What kind of substitution is good? We say that let x to be 2 sine theta. Therefore, dx equals to 2 cosine theta d theta. Okay, now with that, then the 4 minus x squared, that will be 4 cosine squared theta to the power of 3 halves, and then this already taken out, the dx now becomes 2 cosine theta d theta. Sorry, this is d theta here. Now the boundary will be from 0 to pi over 2, right? Because when you plug in 0, that's when theta equals to 0. When x equals to 2, the theta is pi over 2. Now let's clean up. 8 square root of 2 over 3, integral from 0 to pi over 2. This becomes 8. This becomes cosine cube theta times 2 cosine theta d theta. Okay, now if I continue on the right hand side here, there will be 64, 120. Let's see if you're a little bit, you see that one? Okay, now on the top there, it will be 128 radical 2 over 3, that cleans up the coefficients, and then integral from 0 to pi over 2 cosine to the 4th theta d theta. That's what it boils down to. Okay, now from here, then we will do double angle thingy. This is equals to 128 square root of 2 over 3 integral from 0 to pi over 2. Now you know that this is cosine squared being squared, and cosine squared is 1 plus cosine 2 theta over 2 being squared d theta, right? Okay, now later on, 2 squared is 4. If you divide that by 4, you get what? 32. So 32 radical 2 over 3 integral from 0 to pi over 2, and I will FOIL the top. Well, 1 plus 2 cosine 2 theta plus cosine squared 2 theta d theta. And then this is equals to 32 radical 2 over 3. If you want to integrate this right now, that's okay. Let's do it. So b theta from 0 to pi over 2, right? And then plus sine 2 theta, again is from 0 to pi over 2, plus, no, we can't integrate that right away, but I can do double angle again. Okay, I can do double angle again. That will be 1 plus 4, I'm sorry, 1 plus cosine 4 theta over 2 d theta. Okay, 32 radical 2 over 3. Here this will be pi over 2, and this tiny thing here, because the sine pi is 0, sine 0 is 0. Okay, and that one, when I integrate, I will get 1/2 times theta plus sine 4 theta over 4 from 0 to pi over 2. Okay, I factorized the 1/2 out already. Now this will then be, let's just do it over. This is pi over 2 plus 1/2 times, when I plug it in, this pi over 2 again, plus 0. Okay, from here is algebra. It's 1/2, 1/4 plus 1/2 is 3/4. Okay, the 3 cancel. The force of this will be 8 radical 2 pi. Oops. Okay, well, anything from here is actually algebra, right? Okay, this is for summer 2009 math 263 test 3 number 9C.